So hello. I want to a little bit test and touch the area which is, I think, not very popular in general. Not I wanted to say in Poland, but it doesn't matter actually. How to test network protocols, why we should care about this, and on very basic, simple cases, explain and show how easy it can be. Of course, not always, but in those specific examples, I would like to present this. A few words about me. So I work right now at Rockwell, almost 12, not 12, a little bit more than 12 years. Before I worked in Sabre. Mainly I was responsible for the migration of the database, but previously also I worked on the network protocols. I was responsible for the storage protocols like FTP, iSCSI, Samba. So very similar to the topic which I want to present today. Okay. Plan for the presentation. So why we should care, common issues with testing protocols, reverse engineering. In very basic step, I want to explain how to approach this topic. Just two tools which I want to a little bit more touch and explain how we can use and involve in this process. And two demos which I want to present. I think this is the most important and the most interesting part from this presentation, because I will just simply do this, not only talk about this, why, but I want to show how to approach this. And of course, on the end, we can discuss some questions. Why we should care? So if we think about testing, automatically we think about fields, software, web application, .NET application, Python application. And we know that we have to test it because there are some issues, and those issues may affect, of course, us and the customers. But there is ISO-OSI model, as you can see on the right side. And there is plenty of layers, 7. And all of this single layer is also the code, which parses data from the input. And we have to think about this. Of course, not always it is important. Nevertheless, there are issues, like in any other code which is written. Okay, so how to test? When we think about classic functional tests, we think about ISTQB approach, which simply very often is based on the equivalent classes, boundary values, and by this analogy, we can also think about protocols. So the protocols also have fields, also take inputs from the user according to the RFC, according to the software requirements, to the functional requirements. There are some values which can be taken and successfully proceed, and some of those should be rejected. Some error code should be sent back to the client or the application. All right, so this is the one approach which we can take. But very often, when we look, when we're Googling on the internet and we are asking or trying to find something about network testing, we're finding this fuzzing technique or fuzz testing. And there is plenty of tools which we can use very easily and adopt. I will show you in those two demo how we can do this. Adopt to our needs. Even for very low-level protocols, it can be taken, and very quickly we can generate some issues, trust me. All right, when we talk about this, this is the definition from the Wikipedia, but when you will try to Google deeper and find some, let's say, low-level information, you can find that there is very often two kinds of such type of testing. One is called dummy fuzzing. And the dummy fuzzing is just, we don't care about what is expected on the second side, other side, it can be client or server, never mind. We just send some data. And we are looking for issues, observing the application. And another type of fuzzing, it's called clever, or it's based on the corpuses. We have to build, reverse engineer the protocol, see what values can be taken, what are forbidden, and what can be sent to this. And just break it, send some improper data. But it is somehow combined with some knowledge about the protocol. It's not dummy. And for dummy fuzzing, there is plenty of tools. I will show one of this. It's called SFuzz, which we can almost use according any tested service, FTP. For FTP, HTTP, Samba, there are dedicated configs, which send some, let's say, logical data or some clever data, which makes sense for the service. But there are also configs like basic unknown, which can be used according to any protocol, UDP, TCP, it doesn't matter. Common issues, it's needed, but very often there is lack of proper libs for this type of testing. It is something that affected me. I wanted to use a library which was prepared by our developers, but when I wanted to send some improper data, the library has a restriction which simply told me, you cannot send this. This is too long. This is not integer, this is not byte, this is not the ASCII chars, and you cannot do this. And we have to think about how to bypass this. So what I typically do, I used to simply create my own, very simple, not the whole lib for any type of request, any type of messaging, but some maybe initial one, something like this. Of course, this is not easy topic. In those demo, it will be very, let's say, straightforward. However, not always it is simple. And the TLS layer. So there was a question from one of the guy who asked me how to do this, how to reverse engineer, how to analyze such traffic. There are some methods. We can do some spoofing according to the application. We can try to verify that there is properly implemented certificate pinning, for example, and the client simply validate the certificate from the server. If not, the topic is very easy. We can use man-in-the-middle attacks or tools, and through this proxy, we can observe the traffic, analyze it, take the data, and then create our own TLS layer and send over this to the tested application. And this is cool, why we should care. So for my colleagues, they are familiar with this, we are affected. But the go-ahead is the very light web server, very often used in embedded devices. Not only, we can also use it in, take it and compile on the Linux, on the Windows, it doesn't matter. But as you can see, there was plenty of issues. I selected some of the most critical of them, and very simple actually. Looking on the top, large host header, buffer overflow, header parsing causes a memory assertion, multi-part form data, memory issue, and again in the post, the crafted host header. Null pointer, so the crash. So it can be surprising, but look on this. This is really cool for me. This is those issues are from the track TCP/IP stack. So Those issues are on the TCP/IP level. It's amazing, but we can also, with, for example, SCAPI, we can test this layer. One of the guy, there was a question from our site about DHCP. So let's imagine that even on the DHCP layer, your client, your device is asking for the DHCP offer, and we can send back to this client. In the past, there was such issue, it's not confidential. In the domain name option, we can send shell-shock payload and simply take control over this device. Of course, this is fixed in most of the Linuxes which we have right now and the kernels. However, it was possible. But back to this TCP/IP, remote code execution on the TCP/IP, IPv4 tunneling, improper parameters, a lot of the problems on very low level layer. Two tools. Oh, before this, reverse engineering. So 6 points, not too much. You will see that sometimes it's very simple. We have to start network sniffing, trigger the application to work, just establish connection, record the traffic, look on the layers, see the data, what is changing. Maybe there are some fields which are just the length of the data which we want to send. Recreate the packets, just in Python, or it can be even pure bash. Send back and see if we can replicate this and if the logic will be exactly the same. And then, knowing that we did this correctly and we see the same outputs and responses, we can start a little bit modify selected packets. So what we need Wireshark, of course. Most probably you heard about this. It's a free open source tool which we can download, or in the Kali Linux it is available on the beginning. We can use it, record the traffic, look for the specific layer, and just try to take this data and understand the logic. And this is something what I will use very often, the export feature. Another tool which is really important to simply start the fuzzing or the protocol tests, Throdamsa. It's not very popular, but I'm really sad about this. This is, please just look on this link, and there is hundreds of issues identified by this in Chrome, some 0 days, in very serious piece of software. This is just, it was difficult to, combine this and set the font really small just to present how many issues, but this simple tool discovered a lot of problems. How it works, it just takes the piece of data, like, I don't know, it can be file, it can be binary file, binary data, and try to malform this. And there is implemented logic, which you will see, I will try to highlight this, which simply analyze the data which we have as an input. For example, if there will be a value of some number as a text, and if the tool will find this number, we'll try to increase this value to see if there is maybe integer overflow, which we can exceed the range of the integer value or the other type of value. If somehow detect that there is XML structure, it will see not close a tag, add additional the same tag, change the value of the key of the value for the specific node of the XML. So this is really cool, and I used this against many different types of software successfully. All right. And demo. I really wanted to do this, online. However, I have prepared movies, and I will stay with this because I don't have chair and don't have additional keyboard, so it can be a little bit difficult just with this setup. So I have movie prepared especially for you. All right. I need to. Okay. I just need to see. Okay. 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 So this is BARP. BARP is rather used for the security test, but it can be also used for the HTTP fuzzing. So I just recorded the request, which my browser did to the server, manually added a value for the page which I want to take. And then in the intruder plugin, I selected specific fields which I want to test. And for the purpose of this demo, I thought that I will replicate the attack which was simply done for the go-ahead server. So I'm just putting the values into the fields, and in the specific fields, instead of the proper data like host, address of the page, there will be put those payloads. I'm just checking the responses. When we exceed a specific length for the header, there will be, of course, proper response code. It should be, according to the knowledge how the Apache works. But this is exactly what we see right now, how the issue in go-ahead was found. Not by me, this specific, but and in this previous movie, which I prepared, okay, there was, I was realized that the host header actually didn't take the value, so I fixed one option, and you will see in the next movie that it is actually done. Let's look on this. Again, I need to move it. All right. You see the picture with my daughter. She will be famous. All right. So again, I just, to fix this problem, which I wasn't aware, I selected the host header, and then there is one option, simply don't keep original host header, and then I was able to put in the host header this long header value. In the go-ahead, there was in the past one funny issue. So they started implementation of the IPv6, and the IPv6 is put in the brackets. And when we forgot to close this IPv6 host header, then there is also a buffer overflow condition. Right now, what I presenting, I recorded this request with the Wireshark, and then I clicked on the hypertext transfer layer. So this is one layer over TCP, and I exported just pure bytes. There is a feature in the Wireshark, and I will save it. And right now, yeah, you can see that there is a request which I saved. It's actually what we expected. In the hex editor, I wanted just to show you that there is return and new line on the end. So in bytes 0D and 0A. And right now I will use this magic tool, which is called Radamsa. I will try. All right. And that's all what we have to do. It will simply take this original value and malform it. There is parameter n, which simply tell us how many malformation should be done, and the seed, what is the vector of this malformation. It is worth to use this seed parameter because otherwise it is totally random, and you will, if you don't record this, you will be not able to replicate this specific type of the malformation. And we can see that, in this, there is plenty of, the header was replaced, and there was such issue in the go-ahead in the past that we could do in the multi-part form, define the same header, the same field many times, and there was memory issue. We can finally overwrite area of memory because nobody think about, I think that, you know, somebody can try to declare the same value, the same header many times. All right. I just wanted to show you also how exactly this radam saw works. So this is one single malformation. I will just do a 10 with the specific seed. And this is the case which I described. So we have ordinal value, like, you know, seconds in the date, and it added automatically. The tool found that there is some number here and extended this to the value which can simply be higher than the size than defined in the code. Also, the host header was simply cut, and the dot was added, which is incorrect. Of course, this is just the 10 malformation, but we can very easily change this to the 100,000, something like this, and it works. We can also use it for the file malformation, but it's perfect for the protocol. Just the O parameter, IP, and the port, and something what has to be put as an input. It's perfect. Another way how we can test HTTP is this one. So the sfuzz, which can be used as a dummy fuzzing tool, but also can be used for specific protocols which are defined. And in HTTP is defined. So what we have to do, run it with the S parameter, port, transport layer definition. In this case, it will be TCP, of course, and the configuration file, which is in Kali stored in this user share sfuzzDB directory. And it started. This can be another way how you can do the HTTP fuzzing and testing. And we can see that there is some path traversal attempts. Some of the data were malformed on another fields. All right. Right now, I will show you a little bit something a little bit more complex. It will be FTP demo. Okay, I just need to check. All right, the second one. So for this, of course, we cannot use burp. It's a little bit different protocol. So this will be exactly the sequence which was defined in the reverse engineering of the for the network protocols. So I'm selecting the interface for sniffing, and what I have to do, I have to trigger the proper communication. So I back to the console, open FTP client. Cool. And then we have to back to the Wireshark and just look for the traffic. So there is a password request, there is username data, the user comment actually, it is called according to the specification comments. So there is 2 comments which we have to need to log in. User then with arguments and the password with the arguments. All right. So the easiest way to start testing this protocol is just those steps. So I just go to the file transfer protocols layer, export bytes from this specific layer, save it, and guess what? And I will use Radamsa for it. It's look like a plain text, but when we use a hex editor, we will see that there is also return new line 0D, 0A on the end. I have to put proper name for the file and generate then test cases. 1,000, 1,000. See it. Let's imagine that you can take any initial message to any type of software which you use and do this. It doesn't matter what type of protocols. Just record it, save it, the specific layer, and then with the simple tool malform and send to the software device, it doesn't matter. To manipulate data, we see that there is, if I correctly saw this, %s on printf values which can be dangerous for the C++ code. We can use this to exploit C++ application, not only the buffer overflow, but also the printf payloads. Okay. Okay, but this was mainly focused on the Radamsa and a little bit on the built-in tools. But let's do something more advanced. Let's create our own FTP client with Python. Okay. Again, Wireshark, FTP connection from our FTP client. Okay. And we have to copy the specific packets, data up to the transport layer. So the user command and the password command. And what I did in this example, I just took first TCP client Python example from the internet. You will see this. I just copied to the notepad the values which were sent over the layer. Okay. This is the IP of my second Kali Linux machine, which is also hosted on this computer. And it is just the example taken from the Google, just for the very simple TCP client, which sent hello world to some client server application. You can find this very easy. But instead of this, I will just paste this specific data which I found in the Wireshark here. And I need to end this with the return new line bytes. Okay, and let's see. I'm just checking how it works. And I receive some banner from the FTP server. Okay, so then I need to recreate the second message from this sequence. This case, of course, is very easy because there is, the complexity of this protocol is, let's say, very low comparing to other protocols. Nevertheless, sometimes it is very simple. So we know that we have to send username comment. We have to wait for the data sent back to us and send the password comment to the FTP server. So I just copied the second line from this loop, paste here, waiting for the answer, but instead of the user comment, I will put the password. I don't know why I just pasted this instead of the writing, but. Sometimes when I do something like this, the code looks rather like the second part of this message. It means just the pure bytes, the hex values of the bytes. It's more often the case. And see how it works. So yeah, login successful. So you see how it is, how easy it can be. So just taking some data over the transport layer, pasting to the Python, sending, and we can try to be a client. Of course, I don't want to send any file. I want to modify the arguments or the fields which I will send to this protocol. So I will try in this line add some additional things. It means that's the upper A, which is very often used for the buffer overflow identification. The value 41 in the hex is very easy to find in the stack once you have some crashes or some instruction pointer overwriting. So you see 41, 41, 41, okay, in this area of the memory it shouldn't be visible. And I try it. And during those attempts, you can see that there is login incorrect, but sometimes I received something what I didn't expect. It means this, the banner or the request for the password. And I will fix this. It will be here. So what I do right now, I'm just adding to the password value some additional string, and the expectation in this case is that maybe there will be buffer overflow. Of course, this specific FTP server was tested. There are some issues, but not this one. Oh, I tried %s, which is example of the printf exploitation technique. So in the printf function, which is very often used, for example, logging or something like this, there is a method of the string formatting which can be used to read and write from the specific region of the memory data. So this is very dangerous. We can use it to add some code to the stack and execute it. And you see that instead of prompting us that the login is unsuccessful, I see the response that I should send a password. And this is something what I didn't expect. And to fix this, we have to add on the beginning one additional line which will wait for the banner from the server when the TCP handshake is done. On the beginning, I thought that maybe there is this password is sent too fast, so I introduced a delay here, but it didn't help. And this is something what, unfortunately, once we're trying to build something from scratch and based on the TCP layer, sometimes we have to look on the various, to the details, how this communication is done. Maybe on the beginning there is just the ask message on the TCP layer without any additional data, and we have to implement this exactly the same in our Python code. I will just right now do first TCP connection without any bytes, just to receive the banner from the FTP server. And then the second message will be the username arguments, and the third one will be the password comment with the arguments. And right now it works, in a repeatable way. So each time I receive the same message on the end, I can modify this, add other things, and then we can use it against FTP. All right. When it makes sense, this is a good question. So when you have a web application and when you have IIS web server or Apache 2 web server, I don't think so. If you have big budget for the test, let's play and make fun. But it makes sense in the embedded world. It makes sense when you have your own network protocol implementation, do something uncommon, use some uncommon protocols. We can test not by this technique which I showed, but with the SCAPI, we can test transport layer, Ethernet layer, and it makes sense because in the track which I showed, there were plenty of issues. With some custom implementation of network services like SNMP, web server, FTP server, very often in small embedded devices, the resources which are there are very poor. There is 5 megabytes memory, some CPU, very slow, and we cannot put the whole Tomcat server or IIS web server or any other. We just have to create something. And when, especially in such cases, there is plenty of issues. So for such cases, it makes sense. It is worth to try. Questions?